All right, welcome to this World Around Us video. This video is going to look at solving gas law problems, how to solve gas law problems. And I'm taking a slightly different approach than the traditional standard approach for solving gas law problems. I took the universal gas law, PV equals nRT, and set it up to look at case 1 and case 2. And the derivation of the formula is in my World Around Us blog on a page which I have linked down in the description. Ultimately, you can do the math and you can arrive at the formula where P1 V1 over N1 T1 is equal to P2 V2, where the 2's represent the second case, P2 V2 over N2 T2. And if you just have this one formula and you just memorize this one formula, and you never have to try to figure out which formula to use. You can start with this formula. And so as an introductory class approach to solving gas law equations, I present this formula to the students with this one understanding of the formula. And that understanding is that if something is not given, you assume it doesn't change. So if temperature isn't given, you can assume it started at 300 Kelvin and ended at 300 Kelvin. Or to make the math easier to look at, you can just put 1 in for anything, because if we have the same thing on both sides of the equation, they'll cancel across the equal sign, and then it comes to 1. So as a step of solving the problems, you can put 1 in for anything not given. So as an example, I've set up a problem, and we have in this case given an initial pressure and a second pressure, an initial volume, a second volume, but no temperature, and the number of molecules is not given. And so for temperature and for number of molecules, we can just use 1. So I'll write T1 equals 1 and N1 equals 1. Likewise, T2 equals 1 and N2 equals 1. Now we have 8 variables, one of which is not given. Now all we need to do is write the formula. And the formula is P1 V1 over N1 T1 equals P2 V2 over N2 T2. The next step is really simple. Plug in and solve. So with our approach to solving any equation in science, any problem in science, what's given, what's the formula, step 3, plug in and solve. Or sometimes we say, what's given and what's looked for, write down the formula, plug in and solve. So I'm going to take this side, I'm going to put my first condition variables values in. So I have 4 times P1, that is P1, 4 times 6 divided by T1 and N1, which are both 1, equals, plugging in on the other side, my P2 is 3. I'm looking for V2, so I'm just going to write V2 because that's what I'm looking for. And the T and the N are 1, so it's 1 times 1. Now we have very simple arithmetic to do. 4 times 6 is 24. 24 divided by 1 times 1. 1 times 1 is 1, so 24 divided by 1 is 24. 24 equals 3 times V2 stays 3 times V2 divided by 1 times 1. So I end up with 3 V2. Divide both sides by 3. And a lot of times students in beginning math actually like to draw in the division process. And that leaves us with 8 equals V2. And it's just that simple. It's just that simple to plug in the numbers, write down the formula, and solve. It works with any combination of these numbers where the missing values are indicated with 1s. That's the key to using this equation, to using this. It's a derivation of the universal gas law, using this for every single case, it works when the not given values are plugged in as 1. It works if temperature is given and pressure is not, or pressure is given and all of that. Now, there is the case where 7 of the 8 variables are given. Now, I want to say this for those who are seriously strict about their science and their math, there is not any combination of P, V, T's, and N's that work. There is the constant R, which in the derivation factors out, but the constant R directs the possible values to something specific. So, if you're going to make up a problem with all of the variables, you can either just use whatever number you want and assume it's on some other, parallel universe where R is a different number, which is mathematically and conceptually okay, but it doesn't model reality very well. So I have an example problem where we'll have 7 of the 8 variables, and we're going to be looking for T2, and these sets of variables do fit with the constraints of the universal gas law, where pressure is in atmospheres, volume is in liters, temperature is in Kelvin, and molecules are in moles. So that constant R, which is factored out because of the derivation process, but the constant for those sets of units is 0.082 if you just wanted to know that. But the R factors out. And so this is a viable set of numbers, so let's go ahead and we'll do the second step. So step 1, what's given and what are we looking for? And then we're going to write the formula. So it's P1 V1 over N1 T1 equals P2 V2 over N2 T2. Now the next step is to plug in the variables. So I've got P, so 2 times 12. 2 times 12 on top, divided by N1 is 1, T1 is 292.68. That's going to equal P2 is 4, V2 is 5, N2 is 2, and we're looking for T2. We can simplify. 2 times 12 is 24. 24 divided by 1 times that is 292.68 equals 4 times 5 is 20. And 2 times T2 is 2 T2. At this point, a lot of students like to cross multiply. There are other ways to solve the algebra and the arithmetic, but a lot of students like to do the cross multiply. Totally valid. Another way would be to cancel some terms out. This could become a 10 and this could become a 1. You could do some canceling and then solve. But we'll do this. Get the calculator. So this term becomes 5953.6 equals 48 T2. The next step is clearly to divide, and again, some students like to write that in. So the 48s will cancel. I like to indicate the cancellation just for the sake of clarity. T2, and then I'm going to divide by 48, the big number, and that gives me 124.03 as my final temperature. The process works regardless of the number of variables you have if you always plug in ones for the things not given. And so one more time, just to look at the formula and then get out of this video, P1 V1 over N1 T1 equals P2 V2 divided by N2 T2. The derivation of this formula is in the blog. That is linked down the description section. Essentially, you set up the R ends up on the bottom of both equations, so it becomes easy math to follow if you really want to see the math. Hopefully this will help you. Again, this works anytime you're given any of the gas components where you have something and then something happens and you get a second state, and just put ones in for anything not given. It will work, and it'll help you. You only have to memorize the one equation, or learn how to use one equation even if you don't memorize equations. Thank you for watching. I hope this video helps you with your gas law calculations. If you enjoyed this video, please click the like button, subscribe to the channel, sign up for notifications, leave me a comment, a question, anything like that. Let me know what you think, and make sure you look down in the description for additional notes and comments and things like that. Thanks for watching again. See you in the next video.